If you go into that, it's going to scream at me. Okay. These are your flight controller settings. Again, those were those. So that home point settings are showing on the screen.
Yep.
You can get them to it from here. Well, most of these, there's your return to home altitude. So it shows you what it does when it returns home. It goes up, comes over. You'll see it in the field. The max altitude, distance limit, sensor status. The sensor status just tells you internals, what the IMU looks like, what the magnetic compass looks like. Now, of importance when you take this drone off is stay away from ferromagnetic objects. Don't take off from manhole lids. Don't take over stop it. This is new with this new firmware. Don't take over reinforced concrete, things like that, because it'll screw up the compass. All right. If you move more than so many miles away from your last flight, it may force you to calibrate the compass, which basically is like doing your phone. It's basically moving it through the magnetic field of the Earth. So if that happens, you'll get a warning up there, and you can just go directly to the screen. Otherwise, you can go to the compass mode here and go to calibrate compass. And it's no more than just picking up the drone and going in a circle with it, and then pointing it straight down and going in a circle with it until it says, okay, I'm calibrated. Very stupid easy. If the IMU needs calibration, you'll also get that through sensor status. It's only saying attitude mode because it can't see the floor. I'll turn those lights on again so it'll shut up. There. Oh, shut up. Okay. It's too dark in here. It doesn't like it being dark.
So I assume it cannot fly at night?
You can, yes. The light should automatically turn on. It's just in this weird area because it's got enough light from the top and it's dark on the bottom, so it doesn't know what to do. Okay, so all your categories on the left, this is the aircraft sensor status. The next one down is the obstacle avoidance. That's on that front page too. This lets you key in those obstacle avoidance areas, so you can go over there. If you had the radar on top, this is where you would turn the radar on. The controller settings, you're not going to change any of these settings either, but this will allow you to link if you have to buy a new controller or something like that because something happens. You would come to this page and you would go to the bottom and send link to aircraft. Okay. It gives you instructions, step-by-step instructions. Whenever you press these, do this, do this, do this. The HD is your video signal coming back. So you have a 2.4 gigahertz and 5 gigahertz going out. You also have transmission of the image coming back. If you're beyond a long range, you'll lose video first, but you'll still maintain transmission. So if you lose video, you can always go to your map view and see where you are in the sky and just start returning home. But this shows you your video output type. Let's see, the output camera view. The next one here is your aircraft battery. Just tells you everything you want to know about the battery. Shows you your charge curves and all sorts of fun stuff. This is where you can also set your battery time. Remember I said the self-discharge? This is where you can program those batteries. I'd leave it at 4 to 5 days as is to just add the longevity of your battery life. They're expensive. They're $700 a piece. You want them to last as long as you want them. Okay. The camera mode here, this is where you can change gimbal speed. How fast does it go when I move it? If I want to go really fast or really slow, I can change gimbal speed, pitch speed, etc. here. Not much else to change. This next one, RTK. This is your RTK positioning. This is the only page you're going to come to on every mission basis. If I'm connecting to DRTK2, which got powered off for some reason, that powered off.
That battery might be on the charger, or it might not have battery in it. I'm not sure.
Look, this one's charged. So again, we're going to set this up over a known point. Now, I'm going to throw another one to you guys. Come on. Oh. That's the goal. guess they changed this now. This is press once and press and hold. Never used to be that way.
Brand new.
Yep.
So how do you usually get the known point? I mean XYZ.
It's usually surveyed ahead of time.
Okay.
If you don't, I have a receiver that I can survey a point in if need be for the course of this mission today. But usually you'll have somebody survey it in or get no control points.
Does DOT have those type of points for drone surveying use?
I'm not sure, but they have RTK station. I mean,
I was gonna say, if you're gonna use the Iowa DOT, all you need is an internet connection, and it has its own node point, so it's broadcasting its location. This station is if you don't have access to that RTK. I'm gonna throw out, how much do you, I don't wanna go overboard, how much do you know about ellipsoid height versus orthometric?
I have read about it, but
Surface of the Earth. Let's do this. Just so you get an understanding of what we're entering. Because when I say, oh, you need to enter the ellipsoid height here, or you need to enter the ground elevation. So this is the surface of the Earth, okay? There are 3 models of the Earth. This is the ground, also called orthometric height. It is the actual ground at mean sea level. Below this is a a gravitational model of the Earth called the ellipsoid. It's actually where the satellite circles. So the satellite is circling in an orbit in the sky, and it's relative to the ellipsoid height. Between the ellipsoid height and the orthometric is called the geoid height. It's a mathematical model. It's updated every 10 years or so by the National Geodetic Survey. There's mapped all over the country, the continental US. The geoid 18 model is the current model. It's basically the differential between the ellipsoid height and this is also, the ellipsoid height is also known as the GPS height, okay? When you look at your GPS on your phone or Garmin, or you're getting the elevation data from the drone, as you've seen written on the photos, it's always the ellipsoid height. So when you're flying your drone that's taking photos, it's recording latitude, longitude, and ellipsoid height. Then we take it through the software and it processes and we say, hey, and load in the geoid 18 model and it converts it to the actual ground elevation. Okay. On average, and by the way, the ellipsoid height actually kind of follows the terrain like this, so it's not average.
So is the airplane altitude also ellipsoid height?
No. An airplane altitude is a barometric height. So its height is calibrated to standard pressure and altitude, which is mean sea level at 68 degrees. And I forget what the pressure is, but I think it's 1092 millibars or something like that. Or 2992. But it also has a radar height, and it also has a GPS height. So that actually has 3 altitudes. This has 3 altitudes in it too. It also has a barometer in it. You just don't see it. That's the fallback. When all else fails, the barometric will work. That's why cheaper drones, you can fly a site twice with a cheaper drone, and you'll get 2 different elevation models because it's using barometric pressure. A cold front came through or something and threw your altitude 100 feet in the air. In this area, the difference, the geoid height is roughly, the ellipsoid is roughly 100 feet below, about 30 meters plus or minus below our feet. Okay. So when you're entering the data, so what I'm getting to this for, if you're using this system, you're going to give the controller this node point on the ground in latitude, longitude, and ellipsoid height. So you'll need to know the ellipsoid height of this point. So if you get a point from a surveyor says, hey, by the way, this point you're seeing out in the field is Iowa State Plains South, northern easting elevation, know that that's projected grid orthometric height. you're gonna have to say, hey buddy, can you give me the GPS height, lat and line, the ellipsoid height? That's what you're gonna have, because that's just the way the DJI system is. It's not smart enough to do those conversions. It doesn't have all the. On the other hand, that's for photogrammetry. If all I'm using this as for is LiDAR, when we process the LiDAR, I can put this node point in when I'm processing, and I can use XYZ. It's a weird system. They're slowly merging systems. So again, if you're going to use the DRTK2, you're going to need latitude in either decimal degrees, longitude, degrees, actually it's D. Or you can say degrees, minutes, seconds if you want to. And ellipsoid height in meters. Always in meters. Plus 1.77. That takes it from there to here. This elevation is what's being reported to the drone. I know it's complicated. That's if you're going to use this system. If you're going to use the Iowa DOT CORS system, you just take what they give you as gospel because it's already been done for you. And you just connect to it. But you have to connect to their system and you have to be on Wi-Fi 100% of the time that you're flying. If you lose connection, your model goes, then you lose accuracy. So, with that in mind, for running the photogrammetry, one thing I didn't talk about with photogrammetry is when you're running your photogrammetry model, your RTK is going to get you almost to the finish line. It's going to give you about 95% of the way in your accuracy. We never fly, and I don't care who tells you this, if you have an RTK drone, yeah, I'm not answering. If you have an RTK drone, you're always going to want ground control points, okay? These are targets, big aerial targets. Either, a giant, checkerboard that looks like this, or a painted X with a circle, or I had a guy that went out there with paint and painted a bullseye with pink paint. He had a PK nail with a flag with a node point in the middle, okay? For a site, something that you can find in a photograph. It can be a sidewalk corner. If I'm at an intersection and I have a sidewalk corner here like this, as long as I can identify that point in among number of photos, what that does is the photogrammetry software takes those ground control points and makes that last minute tweak and adjustment. It rubber bands your model to be absolutely fit your ground control. You can get better accuracy with ground control than without. You need a minimum of 3 points. 1 point is a pivot point, 2 points to find a line, 3 points to find a plane, so you can get that planar adjustment. So for any kind of large site, so we'll go through this. There's a lot more stuff than you thought, isn't there?
Yeah. Does the software have a feature where we introduce those 3 points to it?
The processing software we do. All we have to do is have a physical item out in the field. I'll show you some samples, okay? Let's say we're doing a large, let's say a 40-acre site or something like that. For this particular drone, I'll set control on it like that. So I have known XYZ points that I can identify that would stretch the model out. I may have some checkpoints as well, but I don't need that many. Anything more than 5 to 10 points per site, you get diminishing return for your value. The accuracy just doesn't make up for it. Okay. For a linear, so let's say we're doing a major freeway like this or something, you're gonna want kind of like controls scattered out like this, maybe every 1,000 feet or 2,000 feet or 10,000. We'll say anywhere from 1,000 to 2,500 feet. Kind of both sides of the roads going down the road. The DOT usually paints like giant crosses on the ground. You've seen them in the pavement and stuff like that. Those are aerial photo point targets. And they just key in the middle. They have no X, Y, Z. Do you have to have it? No. Is my accuracy going to suffer if I don't have it? Yes, but not horrible. Okay. Again, photogrammetry, the problem with photogrammetry is I can give you that plus or minus 1 to 2 centimeters horizontal accuracy, but that depends on a lot of conditions. Photogrammetry's been around since like the late 1800s, okay? It's kind of half magic, half science. Lighting conditions, atmospheric conditions, conditions of my equipment, problems with the GPS signal, all those little factors introduce little errors into your model that can accumulate over time and mess up your model or throw you off balance. So the 1 to 2 centimeters is optimal. More likely you're going to get more like 2 to 5 someplace in there overall, both horizontal and vertical. With ground control, we can mitigate that and kind of bring it back down. It's not 100% necessary. I would never make a design engineering model without it. Okay, I wouldn't stake my license on that for anything. But if it's like a drainage study, everything's relative. I can probably get away with it. Okay. If I'm doing culvert studies or a watershed analysis over a large site, I could probably get away without it.
So is there any easy way to get this?
No. Yes, there is.
Arrow points.
Arrow points. So we have, they're expensive, okay? If you don't have, so you guys don't have your own GPS receivers, rovers, or anything like that? Somebody in the
We
department
have
does?
GPS.
Okay. So what you would do is you would set on a point, you could drive a PK nail in the ground, label it up with paint, survey style, put a big X or we'll make, and this is real size, we'll make big chevrons like this out of that foil back temporary pavement marking paint, okay? Or the foil back, sorry, the tape these for temporary pavement marking, or even paint. And the PK nail sits right here, so when you're looking at the photos, that's my known X, Y, Z. And then it's something that stands out. I've had customers go to Lowe's and buy white 5-gallon paint lids, and then put a 60D penny nail, 60D nail to the middle of it to nail it to the ground, and then survey that shot in with the GPS receiver. Right? So you're going to set these points out, and then you can see them when we're processing. We can key those in. I have a little mapping grade antenna I brought with me, so if we want to pop a couple shots for today, we could just use those. Yes, we'll waste our way. Just use those instead. We can get 2 or 3 points. We're not going to fly a whole large site today because of the amount of time it's going to take us to process it, but that's how I would do it. Now we also sell what's called propeller arrow points, and they're large foam targets like this big with a checkerboard pattern, and inside each one they're solar powered and they have a little GPS receiver. And you just throw them out on the site like a frisbee wherever they land. You set them out before you fly with them on the ground. When you're done, you pick them up, and the data they collected gets sent to the cloud, and they send you a coordinate file back for each of those points. And you just do it that way. It takes about 20 minutes.
Yeah, I have those in my car actually. If you're interested in looking at them, we can.
How expensive
show
are they?
A pack of 5 is $5,000, plus a $600 a year subscription. So we usually say, this is the super easy solution, but it costs. But if you already have a GPS rover, just use that. It's a solution you already have. But it does take a little extra work. So you can't. What I'm talking about is the ground control for photogrammetry.
Okay.
Even with an RTK drone, you still want at least a couple points, just for peace of mind. If nothing more than to check to make sure your model's not off in, Canada someplace when you're flying down here. You want to make sure it's accurate. When I say that 1 to 2 centimeters accuracy, that's optimal. Atmospheric conditions, lighting conditions, weather, wind, all those can come into play to throw your model off. Ground control is a way we can use in photogrammetry to tie our model closer back together. There is no ground control needed for LiDAR, however. LiDAR is just that. That's it. Everything's relative to that. So, if we fly with I want to fly at least put a couple ground control points so I can show you how to add them to your model. But if you're, like I said, if you're just doing like a watershed analysis, they may or may not be 100% necessary. It depends on how accurate you can get. God, you missed it. We did photogrammetry theory and
You got it
ellipsoid
right.
geoid models. Yeah,
You
you
got it
did.
right,
Yeah. So if we're going to use this, so getting back to this, the whole reason we got off of this tangent is because I came on this page on RTK positioning. Of all the settings, this is the only page that you're going to mess with quite often. If you're going to be on this antenna, this has to be turned on and it has to be receiving satellite signals. I'll connect to it, but there's nothing that's going to happen because there's no satellites here. Again, I set this up on a known point. I need to know latitude, longitude in degrees, and the ellipsoid height of that point, plus our happy 1.77 meters. So, if I'm just going to use it, if I don't enter the known positioning data there, I'll still get accuracy of up to 4 to 8 inches. So if 8 inches is good enough for my model, I can throw that anywhere I want to without a known point. If I want to bring it down to that 1 to 3 centimeters, I have to have a known point. So I'm going to say, yeah, let's turn on RTK positioning. I'm going to use the DRTK2, and I'm already connected to it. So it says RTK connected, data not in use, because I don't have any satellite data. So it's ready to go. If I want to use the Iowa state system, do you have a login for that? Login information for that?
No.
I have no idea about anything with the Iowa system.
No, I don't have any ID.
So the IDOT system, if I wanted to use a virtual-based disk system, I switch this. So I'm going to be, again, I'm going to come to the settings tab. I'm going to be on the RTK tab on the left. I'm going to switch from source type mobile station to custom network. And once I have that, I have to enter this information. So I'll need an N-trip host. I'll need a port number, typically 2101 or 10,000. I'll need a username and password for the system. And I'll need a mount point. The mount points vary from state to state, system to system, etc. You'll have to fish those out sometimes because a lot of survey equipment, once you connect, it'll give you a pull-down list of which mount point you want to use. This doesn't. You have to know what you have to type it in. So there's different types of, basically the mount point is a protocol used. There's either like CMR, CMR Plus, or RTCM 31, 32, 33. They're all GPS protocols that it uses for communication. Like Missouri DOT uses VRS_RTCM 31. That's the mount point I have to use. Trimble VRS now is like TVN_2011_RT. So you have to know these. Some of them are huge, some of them are small. I don't know what the Iowa do. You can look it up here. My dad. Iowa.
So, but if we use this, we have to have Wi-Fi all the time.
If you use the VRS, yes, you have to have Wi-Fi all the time. If you're using that, you do not. Iowa DOT VRS, come on. Oh sure, my phone, my work phone will go off. My home personal phone will. Is it?
No network, yeah.
Pardon me?
No network, or is it off?
No.
It's just data.
Yeah.